So this is something called Flex Translation. Again, it's another type of content processing module. We have a whole set of Flex modules. So now that I've made these different things, let's do a couple other things here. You can take this content, and we've talked to some customers, for example, say, well, hey, I'd like to be able to take that 3D content and put it out, attach it to quotes maybe, or send it out to prospects or customers or partners, etc. SOLIDWORKS makes something called eDrawings, which is a free 3D and 2D viewer. So if you had this, here's that stereolithography file that just got through making. So you can pass 3D content, the viewer is free, you can attach it to your products and get it out to customers, vendors, manufacturing partners, etc. There's that 3D file. Here's the 2D drawing that you saw flash by. So here's a 2D drawing. So there's a variety of content you can create, and you can share it with a lot of people that could benefit from it. And again, this viewer is free. You can go on the web and download it. Makes no sense for us to make one when there's something like this available to anybody. Okay, next thing I want to do is jump back in the presentation for a second here. So what did we do? Behind the scenes, we loaded a start part, passed some parameters to it, showed you that. Next thing we did is we loaded a set of configured components. Think of these 3D components just like you would a configured component in a rule set. It's a component with a set of parameters. So we assemble those components based on the configurator to drive a new assembly. We then regenerate those components by passing in the driving configuration parameters. And this is what allows us to size those nozzles the right size, make sure that the 15 plate showed up instead of the 10 and all that good stuff. So now we've regenerated a full 3D assembly. Out of that, we can get different types of outputs to support the organization. There's the stereolithography file, there's the 2D. We can get bill of material and embalmed product structure information, which allows us to build product structure. Now I'm going to do the next thing. Okay, here's the brace pack rule set. I'm not going to go over the whole dang thing, but we're just going to go to the bottom down here a bit. Basically, we've got a set of rules that drive content. For example, here's a rule that passed all the stuff that was from the configurator in memory. It's called a content service. So this is a rule that basically told us to pass all the configurator memory over to Flex 3D. Right down here, it says, do they want to create drawings? Well, based on us hitting that checkbox inside of that configurator UI, here's a Flex 2D 3D content request. And essentially, all we were doing here, let me move some things around, is I've got complete control on the configurator of what type of outputs. In this case, I want to create a DXF file. What's the drawing to load? What's the assembly? What sheet number, etc. So if I had multiple sheet drawings inside of ProE and wanted to create different types of output, I can drive all of that. Variety of different output types. Might be creating a DXF file, might be a PostScript file, might be a PDF. All kinds of different types of content can be driven. So here I created a DXF file. Here's a DWG file that was created. I clicked on the next rule. Is it updated? Yeah. Down here, you'll see the 3D stuff. So when I wanted to create that stereolithography file, similar thing. At this point, we were creating an STL file. The only thing that changed was the output type. So it's real simple to add these rules, and you can drive a variety of different types of content. It takes very few rules to drive this process. And this last rule down here queued the whole job to Flex 3D, and all we had to do is say queue the request. So once we set up the types of content we want, created the assembly, this went out here and queued the job over to the Flex 3D server and allowed it to process. One last thing I want to show you is how those nozzles got put in here. So I can get this out of my way. Another rule set, the nozzle rule set. Now we added nozzles on the fly, as you saw, whether I put 2 nozzles or 4 nozzles. And basically, all I needed to do to add that nozzle to the assembly is another type of content request. I'm just going to open this up a little bit. And essentially what I needed to be able to do in the rule was tell Flex3D what I wanted to assemble. And essentially you'll see a set of parameters here, and these are just bringing values from the configurator. Essentially we have a component to assemble into an assembly. So here I specified the component prefix name, which was the code, the extension, where I want it in the assembly, and then the name of the assembly to assemble to. So this one rule was responsible for retrieving the component nozzle, depending on which one I had selected, and assembling it into the 3D assembly. So it took one rule in the nozzle rule set to add that component. And that's really about it. I can put as many components as I want together. I can generate as many types of different content as I need. And we've got rules, what we call Flex3D rules, to do these types of things. So kind of walk you through that a little bit. So, 2 types of processing options. Interactive inline. Well, what that means is we can attach Flex3D directly to the configurator you're running on your desktop and do a bidirectional communication to Flex3D to a running copy of Pro-E on your desktop. So, it's an interactive configurator session attached directly to Flex3D. The benefit of running interactive like this means that the configurator can communicate to the 3D model and Flex3D in process. So for example, if we generated that 3D model and you needed to get information back from that model to then change the user configuration experience, maybe you've got some key dimensions back, you need to calculate some cost or some material usage or something like that. Interactive allows me to grab that information from Flex3D, do whatever I need to do in the configurator, provide the user with feedback or maybe some specific questions to continue the flow, etc. So it's an interactive, point-to-point communication format. Now, because we're on the same box, essentially I've directly linked the configurator to that copy of Flex3D and that 3D CAD engine, and it can support a single user because we're directly hooked in line. Okay? You can't share a copy of Pro-E or Inventor or SolidWorks between multiple users, so it's dedicated to this user. So that's interactive or inline. The way I actually ran it in front of you is what's known as batch. Batch allows us we have what's known as a content requester. It's a web service that allows multiple by design configurator users to generate requests through the web service on another machine or set of machines. We can have multiple processing nodes. The Flex3D automation engine is fed those requests and does all the things that you just saw me do in that demo session. So it doesn't know where the requests are coming from, doesn't care. Multiple users can be processing. So multiple configuration sessions can generate requests. Once it's requested, we build a 3D model and then do the content outputs. You can share it because in this case, again, it's a web service, it's a queue, so any number of configurator users can be generating those requests. At a moment in time, though, only one job is processing. In other words, it's a queue. So Pro-E's sitting back there, Flex3D's sitting there, and it's FIFO. An optional Flex translation engine, which I walked you through in AutoCAD, could take the content that Flex3D created and then do further post-processing on it. In this case, we took a 3D ASYS file, brought it into AutoCAD, ran the Flex translation module, converted it over to a 3D block. And that's what I showed you in the simulator. So again, we can do all this stuff on the back end with a whole bunch of users on the front end driving the process.